Here's a real-world problem that stumps most people. A radioactive element halves every 10 years. After 100 years, what fraction is left? Can you solve this in your head before I show you the trick? One way to solve this is to track the amount of the element step by step. Let's see what happens every 10 years to establish a pattern. At the very beginning, at year 0, we have the full amount, which we can represent with the number 1. After the first 10 years, the amount halves, leaving us with 1/2. After 20 years, this remaining amount halves again, which gives us 1/4. After 30 years, it halves again to 1/8. We can already see a pattern emerging. But continuing this for 10 steps to get to 100 years would be very tedious. There must be a more efficient way to use this pattern. Let's use what we've learned to build a more powerful method. First, let's find out how many times the element will actually halve. We can find the number of halving periods by dividing the total time by the half-life of the element. In our case, 100 years divided by 10 years gives us exactly 10 periods. This means the element halves itself 10 times. So the fraction remaining will be 1/2 raised to the power of the number of periods. For our problem, this means we need to calculate 1/2 to the power of 10. Now let's calculate this value step by step. First, we can apply the exponent to both the numerator and the denominator of the fraction. This gives us 1 to the power of 10 divided by 2 to the power of 10. The numerator is simple. 1 raised to any power is always just 1. For the denominator, we can make the calculation easier by splitting 2 to the 10th into 2 to the 5th times 2 to the 5th. We know that 2 to the power of 5 is 32, so we just need to calculate 32 times. 32. And 32 times 32 is 1024. Now we combine our results. The fraction remaining is 1 over 1024. And we solved our problem. If you like this explanation, please give it a thumbs up. I wish you a wonderful day. Take care.